Hello everyone, I'm Ryder Cario. I recently completed an internship with the Town of Easton Engineering Department. For the internship, I documented the construction of the East Avenue Storm Drain Improvement Project. The goal of this improvement project was to address stormwater runoff and significant flooding that had been occurring in the East End neighborhood. These photos show examples of the flooding that occurred during high-intensity rainfall events along Dover Road, East Avenue, and August Street. While these flood events didn't occur on a regular basis, the potential for property damage was significant.
The East Ave Storm Drain Improvement Project area comprises several sub-watersheds of the Tanyard Branch watershed. A watershed is an area of land that drains all of the stream's water and rainfall to a common outlet. For perspective, here's a map showing the Tanyard Branch watershed in pink relative to the town's boundaries. The condition of a watershed, whether it's predominantly wooded or vegetated, or whether it is developed, is more important for many reasons. For this project, it is important as it determines how quickly rainfall will enter a storm drain or stream channel and potentially lead to flooding. Wooded or green areas are considered to be pervious or permeable, as they are able to absorb rainfall and allow it to pass through to groundwater. Developed land with buildings, sidewalks, roads, is generally impervious, meaning that water runs over the land as runoff rather than through it. The relationship between impervious surface and runoff is expressed in a hydrograph, where time is on the x-axis and runoff or discharge is on the y-axis. In this graph, the black line represents the rate of water flow or discharge off an area with relatively high rates of impervious surface. As you can see, the peak discharge rate happens sooner and at a higher rate than that of the green line, which represents an area with relatively low amounts of impervious surface. Ultimately, this means that in a developed area with a high impervious surface area, like the East End, the potential for flooding is high, as the water reaches and enters the storm drain system more quickly and at a higher volume. If not designed to accommodate these large volumes of water, the storm drain system can be overwhelmed, leading to flooding. Over time, the development of new land puts increasing pressure on any given storm drain system. Consider that when the existing storm drain system was designed and installed in the early to mid-1900s, the town's population was under 10,000. Today, Easton's population is over 17,000. In the Tanyard Branch watershed, the current impervious surface cover is approximately 39%. It is not hard to imagine that the impervious surface cover was significantly less with a population of 10,000 compared to today's population. Increases to the population and impervious surface cover aren't the only things pushing the limits of the current storm drain system and to the resulting flooding. The storms that we see today are significantly more intense than those that occurred less than 100 years ago. The Maryland Department of Natural Resources notes that precipitation has increased by about 25% since the late 1950s, and these increases are expected to continue. A 2020 report by the Eastern Shore Land Conservancy suggests that precipitation volumes could increase another 10% by the year 2050. With increases in impervious surface area, combined with significant changes in storm intensity, the old storm drain infrastructure didn't have the capacity to keep up, and the flooding that has been seen over the last 10 years is the result. Recognizing the need to improve the storm drain system in the East End area, the town of Easton engaged an engineering firm in 2020 to perform a hydrology and hydraulic study of the Tanyard Branch watershed and model the storm drain network. This study looked at the size and capacity of the existing storm drain network, as well as above-ground conditions, such as impervious surface, to better understand where potential flooding conditions might exist. It is not surprising that the result of the study closely matched areas where flooding had historically occurred. But the study most importantly identified the specific lengths of the storm drain pipes that were causing the flooding. And the model that was developed was able to calculate the correct sized replacement pipes so as not to create a new problem in another area. With the deficient areas of the storm drain identified, the engineering firm was able to begin designing the East Avenue storm drain project. The goal of the design was to reduce flooding by safely managing existing stormwater runoff, including anticipated increases in future stormwater runoff due to changes in precipitation intensities. As the first step in the design process, an initial survey was performed to map existing topography and impervious surface, and the location of all existing underground infrastructure, including water lines, sewer lines, gas lines, and electric and fiber conduit. With these existing conditions and constraints identified, the design progressed through a series of design milestones, which were identified as 30%, 60%, and 95% designs. At each of these milestones, review and input was provided by the town of Easton and Easton Utilities. After a design period of a little over a year, final plans were signed. The resulting design included a new linear stormwater pipe system that included 2,100 feet of new or upsized storm drain piping, 10 new manholes, 7 new inlets, 1 new head wall, and 1 plunge pool with the capacity to handle 10-year and larger storm events. With the design complete and funding secured through the America Rescue Plan Act, or ARPA, the town was able to issue a request for proposals for the construction of the project in September 2024. In October of 2024, the project was awarded to a local utility contractor. The total cost of the East Avenue portion of the work was $2.1 million. After the completion of a related storm drain project on Harrison Street, work started on the East Avenue portion of the project in July 2025. Construction began at the downstream end of the project with the installation of a plunge pool. A plunge pool is a large rock-lined basin that dissipates the water's energy before it enters receiving waters. Given the size of the new storm drain pipe and the water volume it carries, over 900 tons of rock were used in the construction of the plunge pool. Starting construction at the downstream end of the project also allowed for the existing pipe to convey stormwater runoff until the new pipe was installed. These constraints included the need to connect to the existing storm drain network, maintain enough fall or slope to convey the water, and to be deep enough to miss existing underground utilities. While some of the existing underground utilities, such as water and gas mains, could be relocated at an expense if necessary, the sanitary sewer system cannot be relocated. Since it is a gravity-driven system, there was no flexibility to go up and over to avoid the new storm drain system. As a fixed constraint, the sanitary sewer system ended up being a key driver of the new storm drain elevation. At the locations where the new storm drain crossed the sanitary sewer pipes, the sewer pipes were 5 to 6 feet below the surface. Combine that depth with the new storm drain pipes having an outside diameter of over 4.5 feet, and at a minimum separation distance, the new storm drain pipe is over 12 feet below the surface for much of its length. Installing storm drain at these depths requires special construction techniques and equipment. For the safety of the crews, shoring of the excavation trench was mandatory. This shoring was done using trench boxes that protected workers and allowed for the installation of 2 pipe sections, or 16 linear feet of pipe before being pulled to the next section of newly excavated trench. Working at these depths, getting 5 pieces of pipe or 40 linear feet installed in a day was considered a good day. The pace could slow to 1 or 2 pieces of pipe per day when a manhole needed to be installed to change pipe direction or elevation, or tie in existing pipe. The largest manholes set were 8 feet in diameter and weighed over 16,000 pounds. Pace also slowed when old, unknown electric lines or pipes were found. These old utilities needed to be verified as abandoned before they could be removed. Reinforced concrete pipe, or RCP, was utilized for the entire project. Despite being heavier and more difficult to install than some alternatives, RCP was chosen for its durability, strength, and long-term performance. Installed correctly, RCP has a lifespan of well over 100 years. The existing storm drain main was 24 inches in diameter for its entire length. The majority of the new storm drain pipe is 48 inches in diameter. This 48-inch pipe will be able to handle a peak flow from a 100-year storm event. It is expected that the flows of this storm event will be in excess of 100 cubic feet per second.
For reference, 100 cubic feet per second is equivalent to 14 of these 55-gallon drums flowing past any one section of pipe in 1 second. Said another way, 100 cubic feet per second is equal to the volume of the water coming out of 330 1 3/4-inch fire hoses.
As the project progressed towards Eastover Street and the end of the new system, the pipe size decreased progressively, with the smallest diameter of pipe being utilized for the new storm drain main being 36 inches. New inlets were also installed in the areas where flooding was most prevalent to help the flow of water into the new system.
Now complete, the East Avenue Storm Drain Improvement Project will safely convey stormwater runoff associated with 10-year and greater storms, significantly reducing potential damage to property. While these projects are costly and can be disruptive at times, it is critical that the town continues to undertake these projects to replace and improve the town's aging stormwater infrastructure. Thank you for watching. If you have any questions or would like additional information, please reach out to the Town of Easton Engineering Department.